Death has puzzled humanity since the dawn of time. What happens when our hearts stop beating and our brains cease their electrical activity? For most of history, this question belonged to philosophers and theologians. But then came Stephen Hawking, one of the greatest minds in physics, who dared to apply scientific thinking to this ancient mystery. Before we dive deeper into this fascinating topic, I'd love to know where you're watching from today. Drop a comment below telling me your city or country. And if you're finding this exploration intriguing, please hit that like button and subscribe for more thought-provoking content about the mysteries of our universe. Stephen Hawking spent his life studying black holes, those mysterious cosmic giants that swallow everything, including light itself. Through his research, he discovered something remarkable that might hold the key to understanding consciousness and death. His work revealed that information, the very essence of what makes things unique, cannot simply vanish from existence. Think about a book burning in a fire. The pages turn to ash, the words disappear, but according to quantum physics, the information those words represented doesn't just cease to exist. It transforms, scatters, but persists in some form throughout the universe. Hawking proposed that the same principle applies to black holes and, by extension, to human consciousness. When Hawking studied black holes in the 1970s, he faced a troubling paradox. These cosmic monsters appeared to destroy information permanently, which violated one of physics' most fundamental laws. Information, according to quantum mechanics, must be conserved. It can change form, move around, become scrambled beyond recognition, but it cannot simply disappear. After decades of research, Hawking concluded that black holes don't actually destroy information. Instead, they encode it on their surfaces like a cosmic hard drive, storing every detail of everything that falls inside. When black holes eventually evaporate through a process called Hawking radiation, they release this information back into the universe in a scrambled, nearly unrecognizable form. This discovery has profound implications for human consciousness. If we consider consciousness as a form of information, a unique pattern of neural connections and memories that makes you who you are, then Hawking's principle suggests this information cannot simply vanish when you die. Your brain contains roughly 86 billion neurons, each connected to thousands of others through intricate networks. These connections store your memories, shape your personality, and create the experience you call consciousness. Every thought you've ever had, every emotion you've felt, every decision you've made has left its mark in this neural landscape. When death occurs, your brain stops functioning, but the information that created your consciousness doesn't just disappear. According to Hawking's interpretation of quantum mechanics, this information becomes part of the universe's vast information network. It disperses, becomes encoded in ways we don't yet understand, but it persists. Consider how information behaves in our everyday world. When you delete a file from your computer, it doesn't truly vanish immediately. The data remains on the hard drive until new information overwrites it. Even then, sophisticated recovery techniques can sometimes retrieve fragments of the original file. The universe operates on similar principles, but with far greater complexity and permanence. Some scientists propose that consciousness might exist as a quantum field, similar to electromagnetic fields that permeate space. In this view, your individual consciousness represents a localized disturbance in this universal field, like a wave on an ocean. When you die, the wave doesn't disappear. It merges back into the ocean, becoming part of the larger whole while retaining its essential information signature. This concept aligns with discoveries in quantum entanglement, where particles remain mysteriously connected across vast distances. Einstein famously called this spooky action at a distance, but modern experiments have confirmed its reality. If quantum entanglement can connect particles across the universe instantaneously, perhaps consciousness operates through similar non-local connections. The implications extend beyond individual survival. Hawking's theory suggests that every conscious being who has ever lived has left an indelible mark on the universe's information structure. The consciousness of ancient philosophers, medieval mystics, and modern scientists all persist in some form, their thoughts and experiences woven into the cosmic tapestry. This doesn't mean consciousness survives death in the way traditional religions describe, with individual identity intact in some celestial realm. Instead, it suggests something more subtle and profound. Your consciousness becomes part of the universe's memory, influencing future events through complex information networks we're only beginning to understand. Recent research in neuroscience supports aspects of this theory. Scientists have discovered that the brain exhibits quantum effects, particularly in structures called microtubules within neurons. These tiny cellular components might serve as quantum computers, processing information in ways that classical physics cannot explain. If consciousness operates through quantum processes, it becomes subject to quantum mechanical laws, including information conservation. Roger Penrose, Hawking's longtime collaborator, developed this idea further with anesthesiologist Stuart Hameroff. Their theory suggests that consciousness arises from quantum computations in brain microtubules. When clinical death occurs, these quantum processes don't simply stop. They transition to a different state, potentially maintaining some form of conscious experience. Evidence from near-death experiences provides intriguing support for consciousness persistence. Thousands of people who were clinically dead have reported vivid, coherent experiences during periods when their brains showed no measurable activity. These accounts often include accurate observations of events occurring around their unconscious bodies, suggesting consciousness might operate independently of normal brain function. Medical professionals have documented cases where patients described detailed conversations and events that occurred while they were clinically dead. Pam Reynolds, for example, underwent surgery requiring her body temperature to be lowered to 60 degrees Fahrenheit and her heart to be stopped completely. Despite having no brain activity, she later described the surgical procedure in remarkable detail, including conversations between doctors and the specific sounds of surgical instruments. Such cases suggest consciousness might not be entirely produced by the brain but rather accessed through it, like a radio receiving signals from a distant station. When the radio breaks, the station continues broadcasting. We simply lose our ability to receive the signal clearly. Hawking's theory provides a scientific framework for understanding how this might work. If consciousness represents a pattern of information, and information cannot be destroyed, then conscious patterns must persist even after biological death. The question becomes not whether consciousness survives, but in what form and how it might interact with physical reality. The mathematics supporting this theory are complex but compelling. Information theory, developed by Claude Shannon in the 1940s, demonstrates that information has physical properties. It requires energy to create, store, and transmit. When you think a thought or form a memory, you're creating physical changes in the universe's information content. These changes follow conservation laws similar to those governing energy and matter. Just as energy cannot be created or destroyed but only transformed, information undergoes similar transformations. Your conscious experiences become encoded in the quantum structure of space-time itself, preserved in ways that transcend biological limitations. This encoding might explain phenomena that conventional science struggles to address. The persistence of memories across generations, sometimes called genetic memory, could result from information patterns inherited through quantum mechanisms. Children who recall details from past lives might be accessing information patterns that survived previous deaths and became encoded in new biological systems. The universe itself might function as a vast storage system, preserving the conscious experiences of every living being throughout cosmic history. This cosmic memory bank would contain not just individual consciousnesses but the collective wisdom and experience of all life that has ever existed. Modern physics supports this possibility through discoveries about the holographic principle. This theory suggests that all information contained within a three-dimensional space can be encoded on its two-dimensional boundary, similar to how a hologram stores three-dimensional images on flat surfaces. Applied cosmically, this means the entire universe's information content might be encoded on its outer boundary, preserving every detail of every conscious experience. The implications for human meaning and purpose are profound. If consciousness truly persists after death, then every action, thought, and decision carries cosmic significance. The kindness you show, the knowledge you gain, the love you share all become permanent additions to the universe's conscious record. This perspective transforms how we view mortality and legacy. Traditional concepts of leaving behind material wealth or achievements pale compared to contributing to the universe's eternal consciousness network. Every moment of awareness, every flash of insight, every act of compassion adds irreplaceable information to cosmic memory. The theory also suggests that death might represent not an ending but a transformation, similar to how water becomes vapor while retaining its essential molecular structure. Your individual consciousness might merge with larger conscious systems while maintaining its unique information signature, like a river flowing into an ocean while carrying its distinctive mineral content. Scientific research continues exploring these possibilities through various approaches. Quantum biologists study how quantum effects influence living systems, searching for mechanisms that might preserve consciousness beyond biological death. Neuroscientists investigate the nature of consciousness itself, mapping neural networks and exploring how subjective experience emerges from physical processes. Computer scientists contribute by developing models of consciousness based on information processing principles. If consciousness can be understood as a computational process, then the information patterns that create conscious experience might persist in natural quantum computers throughout the universe, continuing their operations long after biological brains cease functioning. The search for consciousness persistence faces significant challenges. Measuring or detecting post-mortem consciousness requires instruments sensitive to quantum effects operating at cosmic scales. Current technology cannot detect these subtle information patterns, but theoretical frameworks suggest what such detection might involve. Future advances in quantum computing and sensor technology might provide the tools necessary to test Hawking's consciousness theory experimentally. Scientists could potentially detect information patterns associated with deceased individuals, providing empirical evidence for consciousness survival. Meanwhile, the theory offers comfort to those facing mortality while maintaining scientific rigor. Rather than requiring faith in unprovable religious doctrines, it bases hope for consciousness survival on established physical principles and mathematical frameworks that govern cosmic behavior. The cosmic perspective emerging from Hawking's work reveals consciousness as a fundamental feature of reality, not merely an accident of biological evolution. In this view, the universe itself might be conscious at some level, with individual consciousnesses representing localized expressions of universal awareness. This universal consciousness would possess all knowledge and experience accumulated throughout cosmic history, including your personal contributions to its ever-expanding memory. Death becomes not a termination but a homecoming, a return to the source of all consciousness carrying the unique gifts of your individual experience. The mathematics underlying this theory continue evolving as scientists refine their understanding of information, consciousness, and quantum mechanics. Each advance brings clearer pictures of how consciousness might persist and interact with physical reality after biological death. Research into consciousness survival also explores practical implications for the living. If consciousness truly persists beyond death, then developing deeper awareness and expanding conscious experience becomes humanity's highest priority. Meditation, contemplation, learning, and compassionate action all contribute to the richness of what survives. The theory suggests that conscious development doesn't end with death but continues in new forms. The patterns of information that constitute your consciousness might integrate with other conscious systems, sharing knowledge and experience in ways impossible during biological existence. This integration could explain reports of deceased individuals communicating with the living through various means. Rather than supernatural intervention, such communications might represent information exchanges between different levels of consciousness operating within the universe's quantum information network. Understanding consciousness as persisting information also illuminates the importance of how we live. Every conscious choice creates permanent additions to cosmic memory. Acts of cruelty and kindness, moments of ignorance and wisdom, experiences of fear and love all become eternal records within universal consciousness. The responsibility this places on each individual is both humbling and empowering. You are not merely a temporary biological accident, but a cosmic contributor whose conscious experiences add irreplaceable value to the universe's eternal memory. Your life matters not just for its immediate effects, but for its permanent contributions to cosmic consciousness. Scientific exploration of consciousness survival continues advancing through multiple disciplines. Physicists refine quantum theories of information conservation, neuroscientists map consciousness in living brains, and philosophers explore the implications of consciousness persistence for human meaning. And ethics, The convergence of these investigations points toward a universe far richer and more meaningful than materialistic science previously suggested. Rather than consciousness being an ephemeral product of biological processes, it emerges as a fundamental cosmic principle, as basic to reality as matter and energy. This cosmic view of consciousness provides new perspectives on ancient questions about life's purpose and meaning. If your conscious experiences persist eternally as part of universal memory, then developing wisdom, compassion, and understanding becomes not just personally beneficial but cosmically significant. The theory also suggests that learning and growth continue beyond biological death. The information patterns constituting your consciousness might access and integrate with the vast knowledge accumulated by universal consciousness throughout cosmic history. Death could represent not an ending but a graduation to expanded forms of awareness and understanding. Research into these possibilities continues expanding as technology advances and understanding deepens. Each discovery brings humanity closer to comprehending consciousness's true nature and its relationship to cosmic reality. The implications extend far beyond individual survival to encompass humanity's cosmic role and destiny. As we stand at the threshold of potentially revolutionary discoveries about consciousness and death, we carry forward Stephen Hawking's legacy of applying rigorous scientific thinking to humanity's deepest questions. His work suggests that consciousness, like information itself, possesses an impermanence that transcends biological limitations. The universe revealed by modern physics appears designed to preserve and integrate conscious experience, creating an eternal repository of awareness that encompasses all life throughout cosmic history. In this grand perspective, death becomes not a final ending but a transformation into expanded forms of existence. Your consciousness, with all its unique experiences, memories, and insights, represents an irreplaceable contribution to this cosmic consciousness network. The love you've shared, the wisdom you've gained, the beauty you've appreciated all become permanent additions to universal memory, persisting long after biological processes cease. This understanding transforms how we approach both life and death. Rather than fearing mortality as absolute termination, we can view it as a transition to different forms of conscious existence. The essence of who you are, the information patterns that create your unique perspective, join the eternal conversation of consciousness that spans the cosmos. Thank you for joining me on this exploration of consciousness, death, and the revolutionary implications of Stephen Hawking's discoveries. If this journey through cosmic mysteries has expanded your perspective, please show your appreciation with a like and subscribe for more content exploring the deepest questions about reality and our place within it. Until next time, remember that your consciousness is not just a temporary flickering of neural activity, but an eternal contribution to the universe's ever-expanding memory of experience and awareness.